Hello friends. With today's increasing life expectation, the desire to look youthful plays a bigger role than ever. The hair care industry has become aware of this and also more capable to deliver active products that are directed toward meeting this consumer demand.
Premature graying is something like onset on senescence in hair in seedling stage. In fact, there is a said boundary to define premature graying. However, one genuine question comes in mind as why our hair is colored? And the answer is equally wonderful. In fact, nature use hair tool to eliminate unwanted chemicals from the body, besides other excretory organs. Toxic materials in body has very high affinity with the melamine and therefore adhere to it, which later on transferred to the cortex and go to hair shaft. Color of hair in any human being is basically defined by the presence of certain pigments, and final hair color is some outcome of these pigments. Basically, there are two different of melamines found in skin, that is eumelanins and pheomelanins. However, the eumelanensis is further divided in brown eumelanins and black eumelanins. See the chemical structure of compounds. The first step of the biosynthetic pathway for both eumelanins and pheomelanins is catalyzed by tyrosinase, resulted in formation of dopaquinone. This dopaquinone is converted to pheomelanin, in either way, while the same dopaquinone is also converted into black and brown eumelanin. This is just a flow diagram for the formation various melamines. Melanocytogenesis is a process of formation of melanocytes. As the immature melanoblast from neural crest to skin during embryogenesis, where it developed into melanoblast. This melanoblast proliferate and converted to melanocytes, which may exist as tyrosinase positive or negative, transient amplifying melanocytes. The fully differentiated follicular melanocyte subpopulation found in hair bulb matrix, where they are distributed within the matrix above and around the upper dermal papilla. They transfer the melanin granules to keratinocytes. Stimulation by UVR or cytokines, the ORS melanocytes may be stimulated to migrate and differentiate to naturally repigment graying hair follicles. Melanogenesis in hair and epidermis differ in various aspects. Epidermal melanocyte consists of 36 viable keratinocytes in the immunocompetent epidermal melanin unit, while hair follicle melanogenesis occur in cyclical control and tightly coupled to the hair growth cycle. The fully differentiated follicular melanocyte subpopulation found in hair bulb matrix, where they are distributed within the matrix above and around the upper dermal papilla. They transfer the melanin granules to keratinocytes. Stimulation by UVR or cytokines, the ORS melanocytes may be stimulated to migrate and differentiate to naturally repigment graying hair follicles, as we know that hair growth has three distinct phases, anagen, catagen and telogen. However, melanogenesis closed by the end of anagen. Accordingly, decline in melanogenic enzymes, tyrosinase, GP75, and dopachrome tautomerase activity is also occur simultaneously. Modulation of melanin synthesis and role of extrinsic factors, including UVR, ROI, which ultimately alter, and intrinsic factors the neurosecretion that triggered the synthesis of alpha-MSH/ActHOR through No, resulted in switching on the signal cascades. Thus, the melanoblast shifted to skin cell during embryogenesis, found in scattered way. They transformed into melanocytes with wherever hair follicle formed. As we know, hair growth comprises three phases: anagen, catagen and telogen. Melanocytes in the hair bulb retract their melanocytes and shut down melanogenesis towards the end of anagen. Structure of hair also change with the age, which can be classified in three stages: unpigmented lanugo hair, vellus hair and thick terminal hair. As in any growth cycle, the morphology of hair also change with the age. The pigmentation is maximum in age of 45, then started degenerating. The incomplete maintenance of melanocyte stem cells cause physiologic hair graying through loss of differentiated progeny with aging. The progression of graying is completed with advancing age. More hair follicles remain for longer duration in telogen. Premature graying may reflect a genetically regulated early exhaustion of the seeding capability of melanocytes, some defect in cell activation, migration compounded by environmental factors, inflammation, or psychological stress. Among the internal causes of graying, individual genetic set and epigenetic interplay of individual is important, while smoking and UV radiation can be enlisted in external factors. Interaction of reactive oxygen intermediate with genetic setup resulted in accumulation of mutates, which is add-on by mismanagement of antioxidation mechanism. One has to understand that individual hair follicles can indeed exhibit pigment dilution. The cause of true grayness, dilution of pigment, occur due to reduction in tyrosinase activity of melanocytes of hair bulb are interactions of suboptimal melanocyte cortical keratinocyte and defective migration of melanocytes from a reservoir in the upper ORS. According to recent researches, the possibility of reversing cavities has been raised. An autosomal dominant can be the only reason for the premature cavities. While, among the various others, causes include pernicious anemia, hyper or hypothyroidism, as part of various premature aging syndromes, and atopic diathesis. The molecular action of the melanophore-differentiating and melanogenic genes within melanophores and various regulators, along with their interaction, reversible hypopigmentation can be noted if the cause is nutritional deficiencies occur and could be overcome by supply of the same. For the treatment for the premature graying, various food supplements like biotin, calcium pantothenate, zinc, copper, and selenium can be given. Among the other chemical agents includes large doses of p-aminobenzoic acid, PABA, Puvasol to be effective, ladinoprost, a PGF2 alpha, eye drops, defibrotide, cyclosporine, corticosteroid, etranonate, L-thyroxine, verapamil, tamoxifen, levodopa, cisplatin, acitretin, triiodothyronine, and lenalidomide. However, side effect of all these compounds can't be ruled out. Among the natural treatment: Malaki, Emblica officinalis, Bringarage, Eclipta alba, mooncake seed tree, Stercuia platinifolia, lotus tree, Ziziphus spina Christi, and henna, Lawsonia alba, are usually and safely can be applied. Among the various antioxidants recommended are followings: